All right, so where do you want to start in the review? Either 27 or 32 or both. I knew it was coming. 27, all right. I knew 27 was coming. I just didn't know how long it was going to take. All right, so 27. Michael throws the ball upward, and the height, h of t, of the ball t seconds later is given by this equation. What was the initial velocity of the ball when Michael threw it? 45, because again, initial velocity is whatever the coefficient of our x, or in this case, t term is. So we just steal that straight from the equation. What is the maximum height reached by the ball and the time at which it's reached? Okay, let's think about this for a minute visually. Maximum height. So if I was looking at a picture, maximum height. The maximum height of something in a parabola or a quadratic form is found at the vertex. So how do I find the vertex when something's in standard form? What's that little formula to find the x? Okay, negative b divided by 2a. So all I'm going to do here is I'm going to go ahead. So negative b would be negative 45 divided by 2 times a, which is negative 16. This is negative 32. So once I get that, I believe it's going to be 1.4. Okay. So my x value of my vertex is 1.4. Now I don't have an answer yet. I just know that I'm lined up. Now I got to figure out how high it is. I actually need the y value. So how would I figure that out? Something easier than factoring. Plug it in. So all I'm going to do is I'm going to take my equation, and wherever I see a t in this case, I'm going to plug this 1.4 in. So my y value is going to be negative 16, 1.4 squared, plus 45 times 1.4, plus 8. So once somebody gets that cranked out, let me know what you get. Okay? What's that? Oh, geez, 39.64, that's what I've got. And at, the x value tells me the time. So 1.4 seconds after the ball is thrown, it'll reach its maximum height. Okay? So this is always going to be my y value, the height. And the time that it occurs is always going to be my x. Yep, 39.6, or it's 0.64, depending on how far you want to go with your values. Complete the table. Now, here you have options. You can either plug 0, 1, and 2 in for t to figure out what the height's going to be, or if you wanted to, you could go to a calculator and go ahead and just take this expression, this equation, type it in. So again, I always like giving you as many tools as possible to come up with something, because then when you're taking a test or a quiz or whatever it happens to be, you can choose which route you want to go. So I get that all in, and then I just hit graph. And you're like, Hardy, I can't even see the top of it. How am I supposed to know what? Well, remember, I just want values. So if I hit second graph, my table's going to come up. So when it's 0, my height is 8. When it's 1, my height is 37. When it's 2, my height is 34. There are even ways with the graphing calculators you can get that max value, at least the x value of it. But that's for another day. Right now, we got to keep working on being able to do some of the mental things that kind of help us to figure it out. Then we can start doing some of the shortcut stuff. And then finally, find the average rate of change in height from 1 to 2. Okay, average rate of change. Find the slope between 1 and 2. Okay, my time is my x values. My height is my y. So how do you find slope of a line? Whoa. Calculators can go back away, then we'll be able to see it. That's better. Well, what's the formula for finding the slope of a line? Oh, Hardy's getting frightened. If I gave you 2 points, how would you find the slope? I hope not at this point. Oh my goodness, people. It's your change in y over your change in x. So what I'm going to do is I'm going to subtract my y values. And I'm going to subtract my x's. Now, it's important. Did I do that over there? Did I just bonehead it? Yep, I boneheaded it. Because you'll notice as I'm going from 1 to 2, is it increasing or decreasing? To go from 37 to 34 is decreasing. So my slope, which we're going to fix here right now, okay, my rate of change is dropping. So I have to pay attention to little things like that. Better than I did when I put my answer up. I think I put 3. Because little things like that make a difference. Whether, we're increasing or decreasing. If this was a business model and I thought I was making money, and I really was losing money, that would kind of make this difficult. But it's applying what we know about a vertex to find other information. It's an actual app of things. What if? Okay. What else we got issues with? Okay. Anywhere on the review, where have we got issues? 32. Alright, let's see what we got here. Flip page. Graph the following. Alright, let's see. 32. Let's see here. Typically, this is one where a mother graph might come in handy, or some of you may say, well, could I just punch this part in on the calculator and plot some points from that? You can, okay? Either way works. But if I go the mother graph route here, and again, that's basically just going to get me my x's, I'm just going to plug these in. Now the catch, so 0 squared would be 0, plus 4 is 4. Here comes the catch. This negative that's here, there's no parentheses. So what you're actually doing, so let's say for instance we were doing -1. In reality, I'm doing this. I'm squaring negative 1, which would be 1, but then I'm putting the negative on it. So negative 1 plus 4 is 3. And again, this is going to be symmetrical. 2 squared is 4, but again, it's going to be negative 4 plus 4 is 0. And I'm not going to use the whiteout today. Is this going to be a solid or dashed parabola? Dashed because there's nowhere equal to. So, let me get my dots plotted here. So I've got my parabola working here. So, now what? How do I figure out where to shade? Okay, test point. Where should I test? I like 0, 0. So I'm testing inside the parabola. So let's see. F of x is just a fancy way of saying y. So 0 is less than 0 plus 4. Is 0 less than 4? Yes. Since that's true, I shade where? Yes. We shade where the test point is, which is inside. A little here and a little there. That helps. That helps. One other suggestion I'll make while we're waiting on the next one here is that if you find there's a section that you're really having issues with, you're like, dang, there's like 5 problems from 5.7. I didn't even try them because I didn't know what to do. Once you go through some of these and start to see what answers should be, go back tonight, go into that section, maybe try a couple of odd problems where you can see what the answer is at the end or something like that. You've got to keep reinforcing because you may just look at it now and go, oh, I can do 32 now. Then you get to tomorrow and you're back in the same dilemma you were today. So just make sure to keep trying some of these out. What else we got working? Four. Flip that through here. Alright. 24 looks like it's going to be complicated, but it's not bad. The impedance in one part of a series circuit is 7 plus 4i ohms, and the impedance in the other part is 12 minus 6i ohms. Add these complex numbers to find the total impedance. So basically, all I'm telling you is combine like terms. So 7 and 12 is 19. Positive 4i minus 6i is negative 2i, and I'm done. It's nothing fancy with the formulas or anything else. That one word kind of lets me off the hook here and makes life a little bit simpler. That's all I got to do. Others, others, others. Okay, let's kind of move down a little here. Write in vertex form by completing the square, then identify the vertex. Okay, when we're doing vertex form, instead of getting our x's alone on a side, we're just going to kind of separate them. So I'm going to leave a blank space here on the y side. And on the other side, I'm going to leave a blank with my x's, but I'm not going to move the 24. Because remember, when we get to vertex form is going to look like this. Okay, so that's what we're looking to get at the end, what you see in red. The first part's just like completing the square normally is. I'm going to take my b value, negative 12. I'm going to divide it by 2. Negative 6 squared, which is 36. That is what's going to go in each of the blanks. And for those of you that just go right to negative 6 right away, there's a reason I do this. Because now, when I get to my next step, and I have to turn this into the square of a binomial, instead of having to sit here, even though it's not a bad one, and figure out what multiplies to positive 36 and adds to negative 12, I'm just swiping it straight from here. Negative 6 and negative 6 hooks me up. And I'm like, I'm close. These are already set, but I need y by itself. So what's my last step going to be? Okay, subtract. I need y by itself. So there's my vertex form. And then my vertex itself, yep, 6, because again, it's the opposite. This is minus h, so I have to do the opposite to get the actual h value. That gets me to both the parts that I need. Okay. Take a flip over here. 31. Describe a quadratic function that has one real solution. The question here is, how many times is my parabola going to cross the x-axis? Once. So, this would be it crosses the x-axis once. And I want you to actually describe it. I don't want, if you need to draw yourself a picture to remind yourself what it would be, that's okay, but just drawing a picture is not going to cut it here. I want you to put it into words. So what if it was the second one on number 31? Crosses the x-axis twice. Again, it would maybe be down a little lower, and then cross, come under, and then come back up. What about imaginary? It doesn't cross at all if it's imaginary. So crosses the x-axis once with 1, crosses twice with 2, and crosses never or none with 2 imaginary. Because the calculator won't be able to get that for me. Yeah, we can put parabola in there too if we wanted to kind of clear things up a little bit more, but just saying how many types of crosses is fine. This would be the picture of one real solution. No, that's okay. I can speak. I can be loud. Correct, because no, I don't want you to draw anything. I'm just visually letting you see why this is the way it is. I want words. If I get pictures, it's not going to work. I want you to describe it. Okay? So that would be our breakdown verbally, at least the shortest verbal way of describing this. So far, so good.
Can you go back to
Which one? Okay. Get 23 back up here for a moment. No problem. Okay. Yes, I will flash your back up in there. Actually, let me do this. No, I'll give you this in a bit. I like the way I did that here better. All right, I'm hearing we have an issue on 33. All right, let's deal with 33. Now, 33 works a little bit differently than 32 did. because now I have a constant term at the end. So this is one where I'm going to need to use intercepts. So remember, this is plus 3. Mention that up there. So if I factor this, get x plus 3 and x plus 1. And I have to set those equal to 0 to find my intercepts. So if I set x plus 3 equal to 0, I get negative 3. And if I set x plus 1 equal to 0, I get negative 1. So I plot those 2 points. And now I've got to go searching for my vertex. Again, I can either add the intercepts together and divide by 2, or in this case, it's pretty easy to see where it's going to be. So my vertex looks like my x is going to be at negative 2. Don't put a dot there yet. I need to know what y is going to be. My y is simply plugging my x value back in and simplifying it. So now this is different. Negative 2 quantity squared is positive 4. Okay, the negative is not out front like it was here, so it'll come out positive. So 4 times negative 2 is negative 8. So 4 minus 8 is negative 4, plus 3 is negative 1. So my vertex is at negative 2, negative 1. Is the parabola that I draw through those points going to be solid or dotted? Solid, because I have the or equal to. There. Test point. Yay, 0, 0. But now this time we're testing outside the parabola. So again, f of x is a fancy way of saying y. So 0 is greater than or equal to 0, 0, 3. 0 greater than 3. So 33, I will shade inside because I tested the outside and got a false answer. We shade where it's true. So hopefully that helps fix that one up a bit. Other issues to fix up, take care of, simplify. Down here a little. Solve the inequality, write the answer in interval notation. Okay, I have options. We can do them graphically, sort of like what we did up in 32 and 33. What's that? Okay, so we'll go algebraically and do the line graph. We can do that. It'll let us see another way of doing it. If we're going to do it algebraically, we need all of our terms on the x squared side. So I'm going to minus the 56 over. Then I'm going to factor it, because I need to know what areas I'm going to be testing on my line. So I need two numbers that multiply to negative 56 and add up to 1. 8, negative 7. So my points that I'm going to test once I set those equal to 0 is I'm going to have cutoff points at x equals negative 8 and x equals 7. So if I make my number line here, and you don't have to be real fancy with your line here as long as you can find your spots where you are testing here. Okay, so those spots are going to divide up my number line into 3 pieces. The outer ones and what's in between. And I only have to test one place really to see how this is going to work, because it's either going to shade in the middle or it's going to shade both on the outside. Any preferences on what point we use? Okay. Yeah, I was going to say, I'd keep going back to 0 if I could. So if we test 0 out. So I'm just going to use this. So 0 plus 0, that's 0. Is 0 less than 56? So since that's true, I'm going to shade in the region where that 0 is, which is here. So when you go to write your answers, typically, best case scenario, when we do interval notation, we'd say, okay, I'm starting at -8, and it's not or equal to, so I'd go from -8 till it stops. Wait, why did I say that one more time? Oh, on these? Okay. Oh, okay, because I was just looking for a second. I'm like, wait a minute, I don't think I flipped any arrows. I was going to panic mode here for a minute. So that can happen too sometimes. So interval notation, since it's or not or equal to, would be parentheses. And that's how we'd run. If it's the outer ones, that's when we get into the one with the U in the middle. And I think that's how 35 actually ends up working. Why are we whispering? Okay. But that's our thing there. Just make your line, or again, you can graph like 32 and 33. So let's flip back over here. Okay, so 28. Solve using the quadratic formula. Well, the first question, of course, is, what is it? How do I find it? Silence hushes over the room. That's not going to be given to you on this test, so we've got to know this. All right, so I need A, I need B, I need C. And then it's just basically pile right on through it. So, negative B, since B is already negative, that's going to make it positive. So it's a positive 8 that I start with. Plus or minus square root of B squared minus 4AC all over 2A. This is absolutely a test of patience. So 8 plus or minus 64, 5 times 3 times 4, I believe would be 60. So 64 minus 60, somebody already said that's going to be 4, and I agree. What's the square root of 4? Right. Don't stop here. Now, if it was still in radical form, this may be as far as I'd be able to go, but it's not in radical form. It broke down clean. Okay, just a second. Let me finish it up, and then we'll see where the dilemma was at. 8 plus 2 is 10 over 6, but that reduces. 8 minus 2 is 6 over 6, which is 1. I'm willing to bet if you had an issue, it's in one of two places. Either we forgot that it was negative b and ended up with this 8, or if it was inside, did you get this negative 8 into parentheses? Because if you didn't, you're going to end up with a fairly large negative number, like negative 124. So for those of you that go to the calculator on this, I don't think you need it. My suggestion would be, instead of trying to pop all this in at once, I would pop just this part into the calculator and then start simplifying it from there. Because if you forget a symbol and you just go straight to square root, you're not going to know where the problem's at. We got to be like quality inspectors here make sure we're watching for every detail. So absolutely on 28. What else? We're hitting a little of this and a little of that. This is good. We're a little heavy on the back part here, but that part. If you take the advice I've given, it's going to make the opportunity to remember it a whole lot more likely. And again, when we only end up over a semester doing like 3 or 4 full-blown tests, it's kind of important. Any other ones with issues? Or do I go into pause? All right. After our slight pause, 25. All right. Area of a rectangle. So we've got length times width equals area. So I've got to distribute over here, and then I have to make a choice. I've got a number in front of my x squared. So even if I wanted to complete the square, I'd probably avoid doing that here. If I bring the 117 over, now I have options. I could factor this. Okay, I could do slide and divide. That's still going to be a fairly large number. Or I could do what we just did in 28 and plug it into the quadratic formula. Like I said, I've said this time and time again, the quadratic formula is math duct tape. It can be used for everything as far as factoring goes. So if you're kind of iffy, if you don't like the idea of trying to figure out what adds to -5 and multiplies to 234, I don't know if I'd be excited about that. I would probably go to the quadratic formula on one like this, since the numbers were bigger. So if I went that route, I'd have -b minus the square root of b squared 4ac all over 2a. And I don't mind if the numbers get big here, because I'm just going to let the calculator do all my heavy lifting. So I'm like, all right, 5 plus or minus, what big ugly looking square root am I going to get? 4 times 117 times 2. I ended up underneath with 961. And what's cool about this one is 961 is a perfect square. Okay, which is 31. So I have 5 plus or minus 31 over 4. Now again, I can't stop here. I'm going to take this, and I'm going to say, okay, one of these answers is going to make sense. I got 5 plus 31 divided by 4, or I have 5 minus 31 divided by 4. 5 plus 31 is 36, divided by 4 is 9. 5 minus 31 is negative 26 over 4. Yeah, it's a negative. That makes no sense. So x is 9. And my dimensions then, plug the 9 in for x. 2 times 9 is 18, minus 5 gives me 9 by 13. I've been thinking about baking when I was doing this one. But again, factoring would have gotten me to the same place. I'd have ended up with the same 2 answers at the end, but I just would have had to have chosen the positive one, which actually makes sense. Others. Yep. I will be here after today and early tomorrow. My face shown on video. All you see are my fingers. I only get fingers. You do not get to show your face on video. No. So, completing the square. X's on a side by themselves. Check. B divided by 2 squared. 16 is going to be added to each side of my equation. So now, this is my perfect square binomial. I'm just going to steal the number from when I did b divided by 2. So I'm going to use a positive 4. Let's get that cleaned up. I can't subtract the 4 because it's stuck in the parentheses. So to get it out of there, I'll square root to dump the squared. But I have to remember two things here. Yep, 28 breaks down. Plus minus, square root of 4 is 2, square root of 7. And now I can subtract the 4 over. But only out in front. Don't try combining it with the 2. So 21's good to go. When you go to do 22, make sure you subtract the 24 first and get your x terms isolated before you start working, or it's going to be a mess.